Hello everybody, this is a video on charging and discharging a capacitor. So before I start, I kind of wanted to touch on what the goal of this video is so that you know what you're watching before you go through the whole thing. The goal of this video is to understand conceptually how electrons flow when you're charging and discharging a capacitor. And I can't emphasize conceptual enough because I believe it helps a whole lot when you're beginning to learn something new, and before you jump into all the equations and things like that, understanding conceptually will help a lot to solidify it, not only for this class, but I think you'll understand it a lot more if you're going to take things like the MCAT or future classes. Understanding concepts before jumping into the equations helps a lot. So if you're struggling with concepts of how capacitors work, this is a great video to watch. If you've already got the concepts down of how electrons flow, then I jump over to some other videos that are on this page that will focus on solving those equations. So if you're looking for something that's going to solve equations, this isn't that video. This is specifically concepts of how electrons will flow. So if you look here, focus on here, we have charging a capacitor and discharging a capacitor. So right now we're just going to focus on what happens when we charge a capacitor. And this is something you can easily set up and walk through in your own home. All I used was some tiles from a game my wife and I play a lot. It's called Bananagrams. And just any board game pieces that are consistent, you can set it up. We used some dry erase marker to show how this works. So some key things, we got our battery set up over here which is just going to be our power source when we walk through this video. We have our resistor, and it's usually shown through this squiggly symbol. And then lastly, we have our plate capacitor with the two plates. And each one of these is shown with negative charges that go along the wire, and then positive and negative charges on the plate capacitor. So let's jump into it. When we're looking at a system like this where we have wires that are connected to a capacitor coming in from a power source connected to a capacitor, one thing to remember is that wires aren't empty. Sometimes we talk about when we plug something in and current flows through that we're sending the electrons through, but we need to remember that electrons are already in the system. They're already there, so that when something comes in, it's almost like pushing like the end of a tube full of ping pong balls, like we discussed in class. When you push on one end, one comes out immediately on the other because it's already full of ping pong balls. And the same thing works on a plate capacitor. You push in one electron, it'd come in, it'd push all the others, and they would slide up the tube. And that's how flow of electrons tends to work. With a plate capacitor, while we're charging it, one thing to notice is the plate capacitor has positive and negative charges, which cancel each other out, and it has no charge on it. But as we flip the switch and start sending electrons in, we know that the goal is to have current or flow of electrons. So we'd send in an electron, it'd come through, hit the resistor, and a key point is to see if you notice the resistor changes how many electrons flow through. So it's coming through at a very steady pace, hits the resistor, and the resistor only allows a certain amount to come out each time, and that's what's represented by the spaces. So electron comes in, bumps up an electron, which bumps all these guys up, bumps one through the resistor comes down, and once it hits the plate capacitor, this is what we're going to focus on. So once a negative charge hits the plate capacitor, it is going to bump one of these positive charges down, because we know that we know the way charges react with each other. So it's going to bump one of these charges down, which in turn bumps one electron off to continue current. So it'll come through, and this is the whole process that comes through. One more electron comes through, bumps everything down, comes down, hits the plate capacitor, and bumps another positive charge off one end to the other. And then you can see it starts to create like an unbalanced charge in the plate capacitor. As it comes through, bumps off one positive onto the negative, bumps one off, and our plate capacitor in the end, if you follow this route, will come down and keep bumping off electrons until it's reached its full capacitance, until it has no more charges that can be bumped off because it's completely full of positive charges on this side. And so if you remember in class, he showed that when we're charging a capacitor, if you plugged in a lamp to show that current was moving, the lamp started off bright and slowly dimmed because of this concept. When they first came in, there was plenty of spaces to knock off, so there's plenty of electrons that could flow, but as these plate capacitors filled up and up, there was less places for the current to flow, less places for electrons to come in and bump it off. And then once the plate capacitor was completely full, the lamp will turn off, and that's because it ends up looking like this. All positive one side, all negative one side, and electrons can no longer flow. So that leads us into discharging a capacitor. So if we bump over our capacitor and say we plug it into a new source, this could be anything you want, anything that you charge the battery and plug it in. Whether here we're looking at the example of a lamp, it could be a drill, it could be a video game where you have to charge the battery with, or something like a capacitor, and then plug it into your system. This is the same concept but reversed. From charging, discharging allows electrons to flow, which allows whatever you're using to work. So say once you flip the switch, plug it in, the same concept happens where these electrons now will flow down, allowing for one to come in and begins to discharge. It'll flow down, one comes in, bumps another, which in turn bumps an electron off, flows down all the way through, bumps one down, which in turn continues to balance out these charges, bumps one down, until at a certain point we get to this point where we have no more unbalanced charges in the capacitor. We have no more charge that can move, so there's no more current, which will drop the voltage to zero. And that's when you would have to say, okay, my battery's dead now, I gotta slide it back over into whatever I used to charge it and charge my capacitor, where electrons would come in and make it so the plate capacitor is charged once again, or unbalance the charges, so that you can take your battery, plug it back in, and current can flow until that plate capacitor has been balanced out again. So it's a very helpful tool to use. You can use it in so many concepts when you're talking about charges. So if you have any games or pieces, I'd encourage you to whip them out, draw on them, work through how electrons flow, so that when you go to do the math, it's easy to look at a resistor and know that when it's coming in one side, there's more electrons versus less electrons on the opposite side, how a plate capacitor works. You'd be surprised how helpful it is in learning for long-term situations. So